Hey everyone, my name is Sayam and you are watching Cube Simplify. So you have watched the Kubernetes course. I hope you have done. And then the next step is to watch the Kubernetes Operators course. And then we are creating this best practice series. The part one is already out. And in this, you learn about making your operators handle errors gracefully with proper retry mechanisms. So instead of them to just panic and retrying until the API server gives up on it, we learn about implementing a better error handling built in the reconciler itself. So without wasting a time, let's go ahead and dive into this. You will hear from Shubham now. But before that, subscribe to the YouTube channel and share this video in your network with your friends.
All right. I usually start with a problem statement in my videos, but this time I want to do something different. Let's first learn a concept and then we will go to a problem statement and then we will see what we need to do. Let me show you something really quickly. I have a cluster here, and I do have my EC2 instance with a certain spec like this. So this is something we have seen in the video where we talked about how to implement the status update, how do you work with a generation, how do you work with spec. It's just a continuation of that. I will put the link of the video in the description. Now, what happens is, what I wanted to show you is every time you make changes to a resource, the generation changes if you have made changes in the spec, and also every resource in Kubernetes has this thing called a resource version. This resource version is how etcd knows about your object. This is how it is reflected in the etcd. And this is going to change irrespective of whether you updated your spec, whether you updated your label, you updated your annotations, you put any changes in your object, whether it is spec or anywhere. This is going to be changed. Whether the generation will only be changed when you actually update um, the spec of your operator or of your resource. So let's do some changes here. I'm going to say testing, and this is a change. Now, if I save and quit this, you see what happened? We went from generation 4 to 5, and there was a different number for the resource version. Now, to show you something that it does not really matter what change was there on on the object, if I just make a new label and I would say cloud GCP. Now, this is to show you that we are not making any changes on the spec, but rather a metadata change. But even that, if I save and quit, you see, this changed. The resource version did change. It did not change the generation because we didn't make changes to the spec of our object, but the resource version changed. Just to quickly show you something else, environment, and I would say production. Now, right now, the resource version is 42331, but if I save and continue, that's going to change to something else, and it is 42345. And that's something I wanted to show you. It does not matter where you make what change in your object. If it has changed, it's going to get a new, the change is going to be committed to HCD, and every commit is going to have a new resource version. So now that out of the way, let's move to the problem which I was facing and that got me to record this video. Um, Now imagine this is what you were doing, and this is something what I did. I felt the problem, and imagine this is what you are also doing. So you have a requirement. Let's start with it now. You have a requirement where you want to make an operator, right? You want to make an operator that is going to work, and that's eventually going to give you a VM running somewhere. It could be in Amazon, it could be in GCP, it doesn't really matter. What this VM is going to do is eventually this virtual machine is going to be added in your cluster as a worker. So think of this as you're making a scaler. You're building your own custom auto scaler, and this is something what I felt when I was working on a similar project. Now, when you are writing an operator, you know you will be writing some custom resources, and for that, you will be needing some custom resource definitions. So, when I was working on it, I decided my custom resource definition to very simply look like this. So, the kind was a node pool, and this will define the number of nodes that I can have. So, a node pool resource would be defining how many maximum nodes can I get, what is my target node, what's the name of my node pool, and also a very simple configuration like how big the node should be, how much disk do I need, and how much memory um, am I gonna need in that particular node pool. You can think of this node pool is going to create me a node which is going to be in one of the cloud providers somewhere, and that is going to be then registered in my cluster. The thing is, a node pool can be created manually. When I create this custom resource, let's say I have built my operator. My operator has the knowledge of creating a virtual machine. My operator has the knowledge of registering that into my cluster. Now, if you really want to start using it, when you create this custom resource, you can make changes on these target nodes. You could say from 0 to 1, and your operator is reacting on that change. So, what it sees is it sees right now I've got like 0. Let me change to a different color. Right now, I've got 0 nodes of this configuration. The user has asked me to create one node, and I'm going to go and I will give them a node. This is what a very simple operator that you wrote. You also have not just this spec here, but you also decided to give a status of to someone who is looking at your node pool. So this status has a key called scale operation, and this is usually inactive if your operator is not doing anything, which means if your operator is not busy creating a node or registering that to the cluster, it doesn't change from inactive. However, this scale operation changes. This scale operation changes when when you are actively creating a VM in a cloud provider from inactive to active. And this is what you wrote an operator for. This is something similar to what we did in my Kubernetes video of how to build your own operator that manages EC2 instances, similar to what I was working on a project in my company. The thing is, you were able to create these resources manually, which is a node, because you have an operator, you deploy or you create this custom resource. Based on the custom resource, your operator runs and it creates you a node, and everything is happy and healthy. However, you decided to take this thing one step further. You said that instead of me deploying the custom resource and then I do kubectl edit node pool, and then I will go from 1 and change this to 2 and save and quit, and eventually there goes another node. This was node number 1, this was node number 2. I don't want to do this. This is a scaler. This is not an auto scaler. So what you decided was that this kubectl edit node pool, or in the end, the increment to this target node, this target node should actually happen on a certain event. And you decided that this event should be a pod being in a pending state because of CPU or memory. Now, you know that a pod could be in a pending state for so many reasons. The pod could be in a pending state because there is no secret that the pod is referencing to, or a persistent volume is not available that the pod needs. The thing is, you have the logic where you list on all the pending pods, you find the ones which are actually pending because of CPU or because of memory. You see, if the memory that the pod is asking for, let's say, if the pod is asking for memory which is around 28 gigabytes, um, and then you have the logic that yes, because the pod is asking for memory that is less than this 96 gigabyte, if I create a node, the node will be enough for my pod to be deployed. You wanted to have this trigger, so you have this as an autoscaler. Now, what you do for all this, let me quickly go and delete this because we don't need it. What you decided was that I'm gonna write another controller. So there are two controllers right now which are working in your operator. I think it makes more sense. Let me just quickly say you can have one single operator which can have multiple custom resource definitions, and also multiple controllers there. So you said, right now, I have one custom resource definition, which is called a node pool, and there is an operator that reacts on top of that, and that's going to be the node pool operator, which is eventually the one that creates you a virtual machine or a VM, somewhere in the cloud. You then decided, because you wanted to make this an autoscaler, you say, I'm going to have a new custom resource definition, and that's called an autoscaler. Let's say you create a new custom resource definition and you name this as autoscaler, and then there is a autoscaler autoscaler operator. This autoscaler custom resource is very simple. It just says how many, or how long to wait before checking for pending pods. Let's say frequency, for example. You can say that my autoscaler operator should look for pods every 5 minutes. This is the frequency that you are configuring in your custom resource definition. So this might look something like, let me just quickly go and write a YAML for this. This would make more sense. Um, so your kind will be autoscaler version 1. Then we have the metadata. Wait, am I doing something wrong here? Let me quickly just get the API version and kind and metadata. So this is what I was missing, because every resource needs this. So I have my API version as compute.example.com v1. Kind is autoscaler, and then we have the metadata, the name my autoscaler, and then you could have a spec. Essentially, when you are working with Cube Builder, you create the spec, you define the spec of your custom resource. In this case, I would have the list of namespaces to target. These are my prod namespace. Then I have my search namespace, and then I have my real money maker namespace. These are the namespaces in which I want to target. If there is a pending pod in these namespaces, then only I want to scale. Because there could be people creating dev projects, and I don't really want to care about if there's a pending pod because of CPU or memory in the dev project. But if these projects are there that has a pending pod, we want to be creating or reacting on that event. Then you could say frequency, and you can say 5 minutes. So every 5 minutes, your autoscaler controller will check the pending pods in the list of namespaces to target, and it will react on top of that. That's simple. So you decided that I'm going to write these two custom resources, and I'm going to write these two different operators. This operator creates the VM. This second operator just finds the pending pod. It just finds the pending pods. Now, because what would you want to do if you have found a pending pod? You would want to create a VM, right? Because there's a pod pending, you need compute, and you would want to create a VM. The thing here to notice is many times you might find yourself in a situation where you have custom resources, you have multiple operators, and they talk to each other's custom resource, not just their own, but each other's resource. In this case, for example, the autoscaler operator, once it has found some pods, what this would do is it rather than this creating a virtual machine, it updates the custom resource called NodePool. Essentially, think of this as kubectl edit NodePool, and then you update the number of target nodes. Let's say whatever the number was, 2, you change this to 3. And because you update the custom resource called NodePool, the NodePool controller will see this change and it will eventually create you a VM, and then your VM will be registered as a worker. The thing here to understand is a different operator, which is our autoscaler operator, is using a different custom resource. This is not, only working on its own custom resource definition. And you will find this happening a lot. And that's where things get interesting. So let's draw a timeline on what actually happened. So you start from the very beginning. Uh, Imagine a cluster where you have your operator, your resources all running. Now, what you do is you install or you create a YAML for the node pool, which is essentially something like this, which we already have here. So I'm going to go copy this and let's paste it over here. Oh, okay, that was something I was expecting. Let me clear that so this becomes a bit more easier to work with. Should have copied this somewhere. Okay, so let me quickly just copy that and keep a fresh copy of this in case I need it in the future. So see what happened. You created a node pool. You created a node pool resource here, and you define the target nodes as not 0, but you define the target node as 1. Or let's say it's 0. To begin with, it is 0. All right. So you're not doing anything. You just say, I want the resource to be there in my cluster. I don't want it to do anything, but let's let it be there. And let me quickly go ahead and get this here. I think we can just get from carbon.now.sh here. This is my YAML. I'm going to copy this image, and here is my custom resource definition, or rather the custom resource for the autoscaler. So these are two CRs that you have created. I hope this is making, this is going to be clear. The two custom resources eventually, because you have two custom resources, you also have two operators, but the operators are not doing anything. So the reason why they are not doing anything, for this one you have the node pool operator, for this one you have the auto scaling operator. They're not doing anything because first, your target node is zero, so nothing needs to be done. And also because you don't have any pending pods in these namespaces, so nothing is being done. Now, let's say you manually went, and you said that I'm going to create one new node from the NodePool operator. What you do, the first thing you go ahead and you do is kubectl create, kubectl, say edit my node pool, which is a short form NP, and you change this target node from, you change this target node from 0 to 1. All good. This operator starts working. It is working. And because you made a change in the spec, a new version would be there, a new, for the same object, the generation is going to change from 1 to 2, and this is also going to be updated to a number X, Y, Z. That's all good. This would be updated. Now, coincidentally, while this operator is doing its job, you found a pod which was pending in the prod namespace. See what happens. You found a pod which was pending in the prod namespace, and you have configured your autoscaler operator that if pending is found, you're going to update the custom resource. You're going to update the custom resource, which is in this case the node pool. So if you found a pending pod, you update the custom resource, and this is same what you're doing. Kubectl edit node pool. Kubectl edit node pool. Keep this in mind that this all happened while your operator was working. While your operator was working. Now, what you do is you edit the node pool. Now, this is going to move from 1 to 2 because uh, from 0 to 1 was you did this manually, kubectl edit node pool, and from 1 to 2 was done by this particular operator while this was running. Okay, while this was running. Now, what's going to happen? Not just the target node is changed, but the generation also changes 3, and this goes from xyz to abc. Okay, and this is all done. It's done, it's working. Once this operator will finish, you might want to update this custom resource back, because when you start working, you change this from inactive to active because your operator was running. And when the operator is done creating a virtual machine, registering that to your worker, to your cluster, you might want to update the object from active back to inactive because it's not technically doing anything. And that's where you're going to have a problem. That's where you're going to have an issue. See, when your node pool operator started, every time, and this is how it's going to make more sense. Let's say you have a custom resource. Its resource version is 1, and you start an operator based on this custom resource with the resource version of 1. Every time your operator sees that there was a change on my custom resource, the first thing it does is it downloads or it caches the object. So if your custom resource had resource version 1 in HCD, here as well, your operator knows that the version latest is 1, and the operator starts doing its work, whatever it is doing. Now, someone or you or another operator, another controller it updates this particular custom resource. And this changes from 1 to 2. Your operator still thinks that the latest version is 1 because it hasn't gone to HCD to get the latest copy. It didn't know that the operator version has changed. It doesn't even have an idea about it yet because it's still running. So while your operator has an older version of the resource, you went ahead and you updated this custom resource in HCD. Now the resource version is 2. Now, when your operator is done, and usually you might want to update the object. Imagine this was a custom resource for the EC2 instance use case that we have been talking about. Now you got the spec, the resource version was 1, you create the VM, you got the public IP. Maybe you want to add the public IP in the status of that object because every object has spec and then the status. You want to update the public IP in the status. You try to update the object for which the resource version of the object was still 1. And that's where the problem happens because when you try to update the object, you essentially want to commit into HCD. So you are telling HCD that, hey DCD or hey HCD, I want you to update an object whose name is so and so and so. HCD doesn't care about the name, it cares about the resource version. So you are saying, update the object with a resource version 1. And HCD says, there is no such object whose resource version is 1. I have some whose resource version is 2. So it looks like you either have an older copy of the object or you are clearly doing something wrong. And that's what you need to fix. And this is the problem that happens when you are working with more than one controllers where each controller is, touching a different custom resource. And this is called a conflict. You might have seen this error at some places. You might have seen this, that the object that you are trying is old, get the latest copy of that object. So essentially, if you really want to update this object, what you would do is, before writing to HCD, because your object update has failed, what you technically do, you get the newer copy from HCD. You get the newer copy from HCD, and now your resource version is 2. And then you will then update, you will retry the update object um, task, or you will try to update the object again. And this time, because you are making a change in HCD for that object, its resource version will now change from 2 to 3. See, every time, anytime anyone makes any changes, you're going to have a new resource version. When you create the resource for the first time, let's say the resource version was 1, and that's what your operator started with. Now, this guy made some changes to the resource version went to 2. So you try to update on an older version where in HCD there was a newer version, it failed. You fetch the new copy and then you try to update. And because the last resource version was 2 and you are doing an update, this changes to 3. And that is the whole story of me trying to explain and come up with this situation. I hope this has made some sense. If not, the comment section is open. You can always ask these questions. But this problem that can happen to you, and this happens because you're trying to update an older version of the object where the object has already been updated by someone external, but your operator did not know about this. So to fix this, there are two different ways in which you can, in which you can fix this problem. The first way is a simple way, or I like to call that a lazy way of doing it. And the second one is a pro way of doing that. Now, it doesn't make sense for me to talk about the simple or lazy or pro, but rather let's go into the code and let's see what different ways are there where you can make your operator intelligent that, okay, the object that I'm trying to create, it has been updated by someone else somewhere. Let me get a new copy and then I will try to make my changes on the new copy. So let's go into the code and then let's see that how it works. All right. So if you look at the code here, let me just quickly walk you through how we are building our API. And in this case, I have a very simple API custom resource type, which is called EC2 instance. This is something that I always use in all of my examples. So if you are working on this best practices series, you already would be very familiar with how do you build an operator, and there's a whole course on Cube Simplify of how do you build this on scratch. We'll probably put the link in the description here. And here you can see I have a very simple custom resource called foo and bar. It has a spec, which is just foo and bar, and this is just a very simple string. Look at the operator. This reconcile function is the main function that runs whenever you make changes to your custom resources. This is the one that tells you what to do. Here's a bit of a fancy print statement, so we can see in the logs of when the reconcile is started from the beginning, and we get the object that is being worked upon into a variable of type EC2 instance. Now, every object that you have, it has a spec, it has a status. That is something you can define in here. For my case, the spec just contains foo and it contains bar, which is another uh, key in my object. However, every object gets some metadata. So every object would have a UID. Every object would have some labels that you do not set in the beginning. This is something which is coming from the Kubernetes API server. Similar to that, every object has a generation and a resource version. So while the resource version, think of this as the version of the object in etcd, and the object generation is the resource, it's a deployment version of the object. So when you create the object for the first time, its generation will be 1. Any change in the spec that you make increments the generation, and that's how you can know what is the old version and what is a newer version that is being worked upon. Now, in this function, which is a reconcile function, it's fairly simple. I'm just trying to simulate a time-taking task that would be done. Usually, your operator, which is in case the EC2 operator in here, it is supposed to be creating an EC2 instance on Amazon. So usually this would go to AWS, make API calls using the SDK written in Golang for AWS. It will authenticate to Amazon. It will give the information that I want to create an EC2 instance with this name, the security group. It should have these tags, these labels, this is the AMI ID, all of this information. And eventually, you're going to get back some response from Amazon. This is something we already talked about in the course for building operators from scratch. But I'm not doing this all. In here, I'm just counting from 1 to 10, and I'm printing. I'm doing a task and the number of the task, and I'm sleeping. Time to sleep. Now, this is where the fun part begins. See, while you are working in your operator, while the reconcile function is running, see what happens. There's an object, right? There's an object. Let's say you just create this object. Its generation would be 1 because it is just created, and its resource version would be some random number which is given by the Cube API server. Now, your object was created, and the operator fetches this object and it stores it into the cache of the object. And this is what's being done here. So this is the part which stores the object into the cache of the reconciler, right? You start and you make some changes. Now the operator runs and it keeps on making the changes. However, what we discussed is that you can have multiple operators trying to write on the same resource. So there could be another operator or a human that goes and does kubectl edit EC to instance, and it goes ahead and probably change some aspects of the custom resource. Now, when you save and quit, when you save and quit your changes, the version is going to be, the generation is going to be from 1 to 2. Here, the old object is with generation 1 and it's XYZ, and this one's going to be A, B, C, and the old object is generation 1 XYZ resource version. This one is generation 2 and ABC resource version. Now, what happens? Your operator is going to make a change. Maybe it's going to update the spec, or maybe it's going to update the status. Let's put it this way. Your call to AWS to create an instance gives you a public IP. Maybe you want to put this public IP in the object status. But this is where your operator is going to cry about. When you say that update, when you run the update function or you make the update call, what you're telling to Kubernetes that I want to put this update onto an object whose resource version is XYZ and its generation is 1, because that's what you are aware of. Your operator does not know that a change has been done outside of its scope. It doesn't know that. And when it goes to do it here, when you try to do an update, you get an error. It says the object that you're trying to talk about no longer exists. I don't have an object with this resource version or this generation. There's a newer object. There's a change in that object that you do not know about. And this is where it gets interesting. So see what's happening here. We try to run some steps in the operator, try to run some steps, and I have a very simple scanln, so I can wait. This is going to run and let me make my changes outside of the operator with kubectl edit. So this would be similar to what any other another operator would make changes to the same object, and until I press enter, this just gives me a little bit of a time. Until I press enter, it will not move ahead. So when I do enter, what's going to happen is I'm updating my spec.bar to a new string or to a different string. And when I try to update, this is where it's going to fail, because I have already made changes to my object outside. The version has changed. The version that operator knows right now is the old one. And this is where it's going to be a problem. Now, if any error happens in your operator, you usually want to retry that. You usually want to retry this. So this is where the return function comes into the picture. The reconcile, this reconcile function, it has two return types, or it returns two values. One is the result. The other one that we are more concerned about, and this is the lazy way of doing things, is the error. So when you have a reconciler, see, the way it works is when you have a reconcile function, if it's going to return an error, if the error that is returned is not nil, Kubernetes is going to see, okay, the reconciler wanted to do something, but it could not do that because, and that is why it returned an error. I would try to run this reconciler on the object again. And this is the self-healing mechanism of Kubernetes. Maybe you could not create the Amazon instance because there was a network problem, and when your reconciler exits, it says the work hasn't been done. Kubernetes will try that again, and this time the network calls would go through. Or maybe you had some permission issues and you fix the permissions, and this is how the self-healing works with Kubernetes. In our case, if we could not update the status, the custom resource, it's going to return an error. And this is the lazy way. The reason why, if there's no error, don't return anything. The work has already been done. We don't return anything. If nothing is returned, the reconciler does not run again. It just waits for a new change to a object that it is responsible for. But see what would happen. Because we will not be able to update, there's an error. The reconciler will run again from the beginning, and it will go through all these 10 tasks. It will go through printing the object and the resource version, but this time it's going to get the newer version because it's this get object, this get function gets the latest object that is being worked upon. And this time it's going to be version 2, which is some change that was made outside the operator. And this time it's going to get the object, print the version, which is new this time, and run through all the steps of your operator, which it should not be doing. There's no reason for doing that. But because you returned an error, it says, I'm going to run through everything in the reconciler. And this is why I have been saying that your reconciler need to be idempotent. If no changes are required, to be made, no changes should be made by the reconciler. Now this time, everything will be fine. And because there's the same version of the same generation and resource version, because you get the latest one that is available, you would be able to update the spec. You would be able to update the spec, and without any errors, you will be returning a nil. And that's the lazy way, because you run your reconciler loop again just to get the new version. You're spending compute cycles. You're spending a lot of time. You're running your reconciler. You're wasting your compute capacity for no reason. Instead of managing the error here itself, you return the error, you let Kubernetes run your reconciler again, get the new version, and eventually move on with the update. And this is what I want to show you. Now, before I can show you, I also want to talk about I have changed my development environment. Before I was using Kind, but now I'm using Wind, or Wind as some people would call that, which is vCluster in Docker. And that is going to be the base of every operator that I build, every development environment that I ever would be needing. Wind is really, really cool, and it gives you a lot of functionality, which I'm sure there are other videos on Cube Simplify which you can look at. But for a very simple example, you could just do vCluster create, and it's going to give you a vCluster in Docker. So exactly drop-in replacement for Kind. And I have my vCluster.yaml file, which if I can show you, it looks something like this. So I'm going to get my worker nodes as the Docker container. Wind also gives me flexibility to create an Amazon EC2 instance and attach that to my local Wind cluster. I'm going to be deploying the default Flannel Cilium, Flannel CNI, and the Kubernetes version that I'm using is 1.3.4. And you can do vCluster, create the name of the cluster. In my case, this is retry. The driver would be Docker, and this works very well on Mac with ObsStack. In case you're using this, you can totally use that. I already have this cluster running from Wind, and you can see I've got these containers, and this is where my Kubernetes cluster is running. So we have a working Kubernetes cluster. We also need our custom resource definitions installed on the cluster. And because we are using Kube Builder, and this is a make file, it has some make targets, make manifest, make generate, and make install. What this is going to do is it's going to create the CRD. It's going to apply them on my cluster, and I would be able to do kget ec2 instances, because this was my custom resource definition, or rather explain ec2 instances. And here you can see it knows about this particular resource. And if I do spec, you will see the foo and the bar examples here. And this is the spec that I wanted to do. Now let me quickly show you this in demo, and let me run my let me see, I should be empty. Okay, good. I'm running my main.go, and this is running the operator on the vCluster in Docker. Now see what happens. As soon as I create an object of type EC2 instance, let me just quickly show you how does it look like. So it would be config examples or config samples compute. This is my EC2 instance which I am creating, right? So let's do that. If I do create, what's going to happen is my reconciler is started on the left side. You can see the generation is 1 because it's the first time this has been created, and the resource version is something different over here, right? The resource version is something different over here. um, However, it looks like it should be stopping, probably. Oh yes, so what happened, this was supposed to stop here so that I could go ahead and make the changes myself, but because I hit an enter, it was given as an input and nothing waited for me. It just moved ahead. But let me quickly do a delete, and then let's rerun this again. So this time I'm going to make sure I do not give any enter. I want this to wait for me so I can make changes myself to the object from outside the operator. So if I do a create, now see what happens. If I do k get ec2 instances hyphen a YAML, this is the generation, and that's the same generation my operator knows about. So that's good. That's perfect. And the resource version also is what it knows. So right now, both of them are knowing the same object. But what I'm going to do is I'm going to edit my EC2 instance, and I'm going to say this change is made while the operator was working on the resource, something like that. Now it's edited, and if you look at this again, this time the generation is incremented by 1, and also the resource version is changed. This tells you that Kubernetes or API server or HCD sees this object differently than what my operator holds here right now. Now, when I press enter, what's going to happen is it will be at this stage. When I press enter, it will try to update my bar. It will change whatever string is there right now for bar, which is testing. It will replace it with this string comes from operator, and when this tries to update, it's going to fail. So let's press enter, and now we will see. Now see what happens. This is the problem. It says operation cannot be fulfilled on EC2 instances. EC2 instances, the object has been modified. Please apply your changes to the latest version and try again. Try again. The way you are trying again now, and this is the stack trace of the error, the way you are doing a retry now is that you simply say panic, I'm returning an error. And the way reconciler works is if you return the error, the whole the whole loop would be running again. And this is what you see here. The reconciler started. This time it got the new version, which is version 2, right? It got the resource version, which is resource version here. It ran through all these tasks. It ran through all of these tasks, and eventually it now knows the latest version that there is. And here you can see when I press enter, it did update the object, which is it went through because nobody else updated the object while the controller was running. It did not change the version. This time when you did an update, a new generation was changed, or rather a new generation was incremented, which is you see here. Any change on the spec updates the generation. So when you create the object for the first time, that was the generation. I make the generation 1. I made some changes manually. That incremented the generation 2. And this time, it went to generation 3 because I was able to update my object using using the controller that we are writing right now. This is a lazy way of doing things. However, There's a better way of handling errors so that you don't just simply say, hey, there's an error. You don't do that. Rather, Kubernetes gives you a package called errors. So if I show you go package um, Kubernetes package errors, and here's this errors package, and this is where Kubernetes has defined, or Kubernetes has defined all the errors that you can get. A lot of times you might see problems like unauthorized. Maybe you say it's forbidden, it's a new conflict that you have. This object already exists, so I can't create that. All of these are already defined in the package, in the API called errors. And this is something that we can use to figure out what type of error it was and what to do on top of that. So let's look at these errors and see how we can make our operator smarter. So instead of quitting and rerunning from the beginning, it gets the latest version here itself. When it fails to update, it says, okay, looks like the operator outside, looks like the object outside has been changed. And let me quickly go and get the latest version right here instead of running the reconciler all again. So let's take a look and see how this is done. All right. So what we're looking into in here is to try to update our object if there was a error. We want to retry if there was an error trying to update our custom resource because the version has been updated or modified somewhere external to our operator. The first thing we need to know is how can we find out what was the error. So this update function here, it does return an error, but it is on you to control that error. It is on you to define how or what that error was. It could be that the object was no longer available. It could be that you did not have permission issues or you did not have permission. It could be there was a 500 error that you got. How do you classify these errors that you are getting when you are trying to update the resource? And for that is what we talked about, the error package. You could do if the error is a conflict error. Something like this is how you can say that if I got an error, I'm using the errors package, and if it was a conflict, this error type is already defined by Kubernetes in the errors package. So if I show you that, go package errors, here, you can see this package implements the functionality to classify the error. No, this is not the one. It's for Kubernetes one. This one. So this defines already given scenarios in which you can run into, and you can probably be given an error. For example, you try to make an object which is already available with that name. When you try to do kubectl create on a resource and you try that again, that's what you get returned. And this is what the error is, that it already is available. One of the other one that we're looking into is the isConflict function. It checks that the error that you got when you're trying to update your object, if it was indeed conflict issue. So you print out that the conflict error was there. Maybe you would want to send an email to the team that, hey, I tried to run my operator and I tried to run the controller, and when I tried to update my object, there was an error. Or you might want to handle it here, right? You might have another errors as well. So it's not the only reason that you could not update the object could be because of conflict. It might as well be that the object you are trying to work on, it has been deleted from Kubernetes itself. So when you try to update that object which no longer exists, you're going to get an error. And again, here we can see if errors is not found, something like this. And here is how you can make here's how you can make your operator more smarter in terms of how to do error handling, how to do error management. In our case, if there is a conflict, we want to retry. We don't want to quit the reconciler. We don't want to do that. We want to stop there and retry rather than exiting the reconciler, returning an error, and Kubernetes will see, hey, this operator did not work properly. It is returning me an error. So I'm going to rerun all the steps again just to be able to update the function. Essentially, at this stage, when you got a conflict error, you want to get the new object version and store in the cache, and then you update the object with the new version, right? That's what you want to do. And for that to do, there is a fairly simple function, and there's actually a package that Kubernetes gives you so that you can implement this retry. For without even that, you could do very simply. So it's going to be the same code that I try to get my object, right? If there was an error, let's get that again and let's update. And this would be very, very simple. This is how you can implement an error conflict functionality. However, the thing is, you can again get an error trying to update your object. It's not like you got an error once and the next time it's going to work fine. You might still get an error. You might still get an error here. And in the end, you're doing the same thing. You are trying to just exit the reconciler because you're returning an error because you got an error when trying to update. And it's kind of like you're going into a loop here. So Kubernetes has a retry package, which I can probably show you. Kubernetes Go retry package. It's somewhere around here. It's in the client Go, and you can use these two functions available. So one of them is on error, the other one is retry on conflict, which is something we want to only try if there was a conflict. The first one is pretty generic on any error. You want to try that again. This one we want to try on conflict, and it has certain options to control how do we want to retry. So this is something that we can use. I would say retry error, and I'm going to use the function retry.RetryOnConflict. You can see I've already got the tab completion. I'm not sure which function or which model am I using, but this is cursor. And let me just quickly do this retry error, and here we go. So this bit makes your retrying a lot more smarter rather than just manually getting, because we are still doing the same. We are getting the object, the new one, from the Kube API server. We try to update. This is exactly what we did even without this function. But what does it give it to you? The one thing that I really like about the retry package, and especially the retry on conflict, is that it does give two inputs to this function. The first one is some default backoff, or it is a set of configuration that tells Kubernetes or tells your reconciler how many times do you want to retry before failing. So if you look on the default backoff, it has steps as four. That being said, it is going to retry four times before giving up and telling to Kubernetes, hey, I tried, I could not update it. So this is kind of like a retry within the retry on conflict function. That's what it gives you. How many times do you want to try again? The duration is the initial time before which your retry function will wait to try for the first time and then the subsequent times. For example, um, it's 10 milliseconds. So for me, it's going to start at 0 to 10 milliseconds to retry. If it fails again, then take another 10 milliseconds, then another 10, then another 10. So 10, 20, 30, 40 milliseconds is how it's going to be. The factor controls what is going to be your duration, or how effectively you're going to retry. So in this case, the duration and the factor, it's kind of like a multiplier. So if I have a duration of 10 seconds and the factor is 5, for the first time when my operator starts, it's going to try on the 10th millisecond, then on the 50th millisecond, then on the 250 millisecond, then after 1.25 seconds is it going to try. So it's multiplying your duration with the factor, kind of like giving you multiple tries within exponential backoff. Within every try, you're going to stop a little bit more and try again. And this jitter is zero point 0.1 up to 1. That's a maximum value. This gives you the randomness between the time on which you're going to retry your update statement. This is especially useful when you have more than one controllers. They all have the same duration. They all start at the same time with the same factor. They all will try to write the object at the same time. And this is something we do not want. So jitter will actually be changing the effective time. So if you would see the duration and factor, this would be something like if your duration is 10 and your factor is, let's say, 5, it would have been, it's going to do 10 milliseconds, then after 50 milliseconds, then after 250 milliseconds, you're multiplying that by the factor. But when you have jitter, which is jitter would be zero point 0.1 or it's 10%, that the randomness that you are involving. So it would be 10% of 10 milliseconds. Within that, it's going to start, right? So it's not going to be exactly 10 milliseconds, but it's going to be probably 8 millisecond, 9 millisecond. Then for 50, it would be 47, 48 milliseconds. A randomness is added. So it is not exactly this particular time on which you are retrying. This helps you when you have more than one controllers running at the same time, and they all have the same factor and the same duration. They try to hit your Kube API server at the same time for updates. And this randomness would be allowing them not to do that at one go. So this retry on conflict function, it takes two inputs. One of them is the configuration of your backoff, which is the step and what we talked about. The another one is a function without any inputs, and this returns an error. Essentially, the return on conflict function itself, it returns an error. You can see here in the function definition, this is the error it is returning, and this error comes from this function, which essentially does nothing, but it tries to get the object, right? It gets the object and then tries to update your operator or your custom resource again. You don't have to have this line because it's the same update that you want from this from the spec that you have changed, and then you try to do an update. You return the error if there is any, because update function also returns an error. So essentially, we are trying to get and update the resource, and we're returning an error if there is any to the return to the retry error variable here. And this is where we can see this bit goes into a loop for your number of steps. It waits for the randomness. It waits for the duration. Then it goes on every factor and added the randomness. It defines the time for four steps or four retries. This is something you can also very well configure. You can give your own configuration. Maybe you want to try for 8 times before you say, okay, I give up now. There was an error. And despite trying for all these retries, the steps that you have, like in our case, is 4. If it is still not nil, that you can only retry. It's not like it's a guarantee that your update is going to go through, but you are retrying. You tried again, maybe 10 times you tried, and here you can say print ln I tried 4 times. Something is wrong with the Kubernetes cluster or API server, because that is what you're trying to hit with the r.update function, right? And then you can simply say, do you want, if you return an error, the reconciler will run again. That's usually, you can do that. It depends on how do you want to choose to build your operator. If I tried many times already, there is an error, I probably will just simply say nil, that I don't want my reconciler to exit and retry again because I just retried. I would rather send something as in send email because it is something bigger. You retry it then again, again, and again, and again. you couldn't update. Maybe the API server is no longer responsive. Someone needs to take a look into this. So here you can see what's being done. We will get rid of the is not found object, and here it's sending an email because something is bigger. So if you could retry, if you could retry, then we just ignore this. We don't want to do anything, because if you could retry, this auto control. All right. So in here, you were not able to update the object and you send an email. However, if everything goes fine, you could say successfully updated the object after the conflict. And because you changed the object, see, this is very important. Every time you make changes to your object, the reconciler remembers it. And when this one loop, this one reconciler function exits, it sees that the object was updated, it will run again. And that's what we are saying. Because the update was done to the object, a new reconciler will be triggered, and we exit gracefully without giving any errors, giving another run to the reconciler because the object was updated properly. If everything was fine, so this is the condition. If the error was something else, because you could have any other problems, this is where you can also control this. That fmt.println, there was an error other than the conflict. I'm going to return the error. Again, you could handle different cases. One of the case was if there was a conflict. You could handle other cases like if the object was not found, maybe it was deleted. That could be another reason why you might want to just not give an error. So you could say if errors dot is not found. If it's not found, then I don't want to do anything. If it's not found, I can't do anything. So I'm just returning gracefully. We are not complaining. We are not sending out an error from the reconciler. We are not telling Kubernetes, try again, because the object does not exist. There's nothing to try. If we don't have the object, we try to update, we failed. What can we do? We can just simply ignore the failure. This is nothing that our operator can control. So you can have more than one conditions. And here also you can kind of like have a catch all for errors. And here you can say there was an error other than the conflict or is not found. And you just then in this case, you really want to return an error and you really want to retry the whole loop for the reconciler, because you already have two cases covered. One of them was if it was not found, you do not do anything, nothing needs to be done. If it was a conflict, we retry. And if we couldn't retry properly, then also we send an email. We don't really run that again. But if we could update, if we could update our object, we simply say, yep, the update went through. When we retried, everything is fine. We don't need to rerun the reconciler because the object was already updated. And in the end, if there was no errors at all, you can see here, we just exit gracefully. So there are many reasons or many places you will find yourself. Do you want to return an error? Do you want to return gracefully? What do you want to do? Every place has its own value. In this case, we try to update, and if there was no error, we simply return because there was no error. Nothing needs to be done. If in case was there any error, that is when you are returning at different places and handling that error differently. But if there was no error in the first time, nothing needs to be done. We can just simply exit out of the reconciler and wait for a new object change detected by Kubernetes. So if I show you this in action now, I'm just going to clean this up a little bit. I don't want to look into is not found errors. And let's just do a go run main.go. I don't have any object right now that this operator would be looking into. So it's just going to wait, and I will do create. So as you can see, as soon as you create the object, the version is the object generation is 1, and the resource version is 80,748. It's going to wait because we ask it to wait. What I'm going to do is simulate that my object was changed outside. So I would say this is now changed, and you can then see its version or generation is 2. The version is also different. If I try again here, you see what happened? It found out that trying to update the object, there was a a conflict error, and it tries to retry there right then and there. It did not exit the whole reconciler. What you are seeing, this one is a new run because you update the object in here, and this is what it says. There was a conflict error. It was retrying. Successfully updated object after retrying on conflict. Because update was to the object, a new reconciler will be triggered. And this again, it makes sense because you did update the object, and here you can see you got the latest version, and everything worked as expected. So this is something that you would be actually doing, and this is how you can make your operator more smarter in terms of not just retry, but how do you handle errors, because there could be errors when your operator, when your reconciler is running. So I think this is a bit longer video, but I really wanted to give you an idea of why would you want to do something, especially when you have multiple things juggling the same object at the same time. In case of when you have more than one operators trying to work on the object at one time, it's always a good idea whenever you are updating your object, whether it is a spec or a status, it's always a good idea to have a retry when you think that this object could be modified by some other controller. If it's not there, if your operator owns that object, nobody else is changing it, or no other process, no other controller is updating that particular object, you don't have to do that. There's no need to deal with it. But especially in systems where there are multiple actors running on the same object, it is a very good idea to implement this retry like we did so. And even then, it's a good idea to handle errors rather than just panicking and telling Kubernetes, please try again. I mean, rather than just returning an error and let Kubernetes do it, it's a good idea that you can do it on yourself right when you try to update. If there was an error, you handle that. If there was a conflict, you retry. So I hope this video makes sense. I hope this video helps you to try to create better operators rather than panicking. Uh, it tells you how to handle the errors gracefully. And if you have any questions, you can let me know in the comments. I would be happy to help, and I would be happy to answer. And that's all we had for this video. And I'm going to see you in the next video of the Operator Best Practices series. See you then.